Hello everyone, welcome to another screencast presentation. Today taking a look at Dynamo. This video came about because I was trying to create a helical structure in Revit. I went through a couple methods. It can be done, but I think it's a little bit more tricky than you would like it to be. Whereas in Dynamo there is a very simple method that we actually have of generating a helical structure. So I'm going to be running through that today. A lot of this information is available in the Dynamo primer. I'm just going to be expanding on it a little bit and also taking it from Dynamo through to Revit and showing you some practical applications and things that you can just start to think about and apply to your daily work. Okay, so I'm going to go ahead and launch Dynamo now. I want to be creating this in my conceptual massing environment. So remember, Dynamo points at whatever document is active at that moment when it's being opened. So I have to first open up my conceptual mass, and then I need to launch Dynamo. Also, just before I launch Dynamo, I'm just going to change my units very quickly, my project units. I'm going to change it from millimeters to meters, just so that I can work with smaller values. So I don't have to type out 4,000. I can just type out 4 to represent 4 meters. It's going to make things a little bit easier in Dynamo. So here in my conceptual massing environment, I can go ahead and launch Dynamo because now Dynamo is pointing at my conceptual mass. I'm going to deal with Dynamo 1.3 in this case. My 2.0 is giving me just a couple issues at the moment. I think I just have to update that to the latest build. But 1.3 is fine. All the nodes are exactly the same. These are with custom out-of-the-box Dynamo nodes, no custom packages or anything like that. Okay, so I am also going to presume that you know a little bit about Dynamo. I'm not going to be going through things in a lot of detail. I'm just going to give a very basic description of what's happening and what I'm doing. So I'm going to start off by creating a list of numbers first of all. So to do that, I'm not going to use my range or sequence nodes. I'm just going to use a code block, which is a really nice fast way of generating a list of numbers. So I'm going to double click and I'm going to type 0.30 ... hash 80. What this is reading out is I'm telling Dynamo to start at 0 to end at 30. Remember, this is meters. And between 0 and 30, I want to have a total of 80 points that I want to create. Okay, and if I look at my list over here, I can see starting at 0, ending at 30 with a total of 80 units. Okay, so now I'm going to jump straight onto the formula for the helix. So this formula is something that we can just memorize. We don't necessarily have to know exactly what's happening. So again, I'm going to do it all in a code block. So I'm going to double click. The formula is as follows. So I'm going to write T, semicolon, enter to drop down to the next line. Then I'm going to type math. Remember, when it gives you the suggestion that comes up here, you want to actually press enter when it comes up with that suggestion to auto-complete it. If you don't press enter, it's not going to function the way that you would like it to. So you actually have to accept that function when it comes up. Okay, so I'm going to say math.sign, enter, open up brackets, math again, dot radians to degrees, open brackets, T, close brackets, semicolon. I'm going to repeat that exact same formula again, except I'm going to replace the sign with the cos. Okay, and literally just like that, that is our formula for our helix. So I'm going to connect my list of numbers up to the T. Also going to right click here and I'm going to put in a point by coordinates node. Okay, and I'm going to connect that output up to X, and straight away I'll get my list of points that appear over here. Okay, so remember, we're going from 0 meters to 30 meters with a total of 80 points. Now I can adjust that at any stage I want. Remember, Dynamo is dynamic, so I can change that 80 to 60, and that will rescale my entire situation over here to give me 60 points between 0 and 30. Okay, so as I connect my sine function up to Y, I will get my standard sine graph that basically appears, and then when I connect cos to the Z, I'll get my vertical height as well, which is going to give me a spiral or helix. Okay, so the next thing that I want to do here is I want to create a curve that goes through all of these points, because I want to place a specific item along this curve that I'm going to talk about a little bit later. So I'm going to come over to my geometry section of my node library over here on the left hand side. I'm going to expand polycurve, and I'm going to use a polycurve by points node to connect those up to give myself a nice smooth line or curve running through all of those points that I've created. Okay, the next step here is to create a curved parameter. So to do this, I'm going to go again to my geometry section, but I'm going to go to my curve section of my node library, and I'm going to go and find a node called point at parameter. I'm going to drop that into my workspace. Okay. So this point by parameter, what this is going to be is this is basically a parametric attractor point, which is going to slide along this curve, okay, dynamically. So I'm going to attach this curve, the output of this polycurve by points node, to the input of this curve node. And the way that this node works is that it uses a value between 0 and 1. Okay, so regardless of how long this curve is, let's say that that start point is 0, that end point is 1. Okay, that's how this node functions, regardless of how long this is. So I'm going to drop in a number slider, and I'm just going to quickly customize the settings. Minimum of 0, maximum is going to be 1. You can't go more than 1 using this node. It's only between 0 and 1. But I want my steps to be slightly smaller, so I'm going to go 0.01. And I'm going to connect that up. Okay. Now if I move this slider, notice that in the background over here, I've got this point that is moving along that curve. Okay, now this is what is going to be used to control the geometry, the size of the geometry that we're going to place along this helix. Okay, something else that I want to do here quickly is I want to rotate this helix. So I'm going to use this geometry rotate function. The geometry that I want to rotate is my list of points. Okay, where do I want to rotate it from? I want to rotate it from the origin. Now, if I right click and I actually start typing out origin, there is a built-in origin node in Dynamo that just starts at 0, 0, 0. I want to rotate this up vertically. I want this to be basically a vertical helix over here. So I want to rotate it around this green line over here, which in this case is my y-axis. So I can just search for my y-axis, connect that up. And my degrees, I can double click to generate another code block, and I can type in 270 degrees. Connect that up. Okay, and there is my vertical helix. Okay, so I'm just going to restructure this graph a little bit, and I would rather connect this information, for instance, to here, so I can get my curve to be vertical rather than that horizontal one that I had. Okay, so I can still move my slide over here. Notice that my point is moving up and down along my vertical helix. And for now, I'm just going to hide these initial points that I started with. Okay, great. So this is the structure that I want to work with over here. So the next step is I want to work out what the distance is from this point that's sliding up and down this helix here, from this attractor point. I want to work out the distance from that point to each and every other reference point along this helix. Okay, so there's going to be quite a few values that are going to appear here. So to do that, I'm going to use a node called geometry distance 2. Okay, and I'm going to plug in my geometry, and then I'm going to plug in my curved parameter over here to the other. So if I take a look at this information here at the moment, I see that I just have a list of values. Okay, this might not make a lot of sense at the moment. Basically what these values are the distance from that attractor point that's moving to each and every other point in this entire shape that I have here. Okay, now what I want to do with this is I want to use these values to define the radius of a bunch of spheres that I want to place at every single point over here. So I'm going to have 80 spheres that are going to wrap themselves around this helical structure over here at the center of each of these points that I have created. Okay, and I'm going to use these distances to control that radius. So the next step that I have to do over here is I need to first of all just create some spheres. So I'm going to type in sphere, and the one that I'm going to use is this one here called bicenter point radius. Okay, so let me show you what will happen if I just skip a step here. So if I just take this information and I just plug it straight into this sphere node over here, what's going to happen is it's going to give me a list of spheres like I've got over here, but they're all going to be the same size. They're going to be overlapping. It's going to be very messy. It's not really going to be what I want at all. Okay, so let me take all of the points. I'll plug it in. I got all my spheres to develop over here, but like I said, they're all the same size, they're all overlapping, not really what I want. I want the distance from that attractor point to control the radius of these spheres. If I just go ahead and plug this into the radius, this is going to do something even worse. Okay, this is just going to create one basically massive mass. Okay, which makes sense if we think about it, because remember the furthest distance, so I'm just going to unplug this quickly so I can explain this. The furthest distance that I have at the moment from that attractor point is going to be 30. Because remember, if this movable point is sitting at the top of this helix, the furthest distance down here at the bottom is 30, and that's 30 meters. So that sphere at the bottom there is going to be 30 meters in its radius, which is why I'm getting such a massive shape. So I need to remap these values over here. Instead of the value from that point to that point being 30, I'm going to remap that to just be 1 or 2 meters, so that these are very manageable sizes of spheres over here. So I'm going to right click and I'm going to type in remap, and I'm going to use this remap range node over here. Okay, so I'm going to take these list of numbers that I have over here currently, and I'm going to put that into the numbers input, and I'm going to give this number, give these numbers over here new values. So the new minimum, double click to put in a code block, is going to be 0.01. So it's going to be very, very small, very, very small sphere. And the new maximum, I'm just going to make, let's say 2. I'm going to put that into new max. And then I'm going to plug this new list of values. You see now, if I compare these two, instead of having 30, I've only got 2. Okay, so 2 down to 0. That's all I basically have instead of 30 down to 0. So my radiuses are going to be much, much smaller. So I can plug this new list of values into the radius. Okay, and I can see what's happening over here now. Starting at the top, because that's where my attractor point is at the moment. And the attractor point to that first point there is a very, very small distance. So the sphere gets a very small radius. As that distance gets bigger and bigger, the radius increases. Okay, now this is also still very messy. There are a couple of ways that I can fix that. I can first of all extend this vertically, give it more space to run. Basically, I can come over here to my initial helix formula, and I can just times that, let's say by 5, to stretch it out vertically a little bit. Okay, now I don't have much of a depth and a width to this. So if I want to increase that, I can times these values over here, times them by 4 for instance, and that'll make my helix wider. Okay, so it's starting to look much, much better over here. Now this is a fully parametric helical structure that I have over here. So as I move this attractor point now, remember that attractor point is going to be sliding along this curve. Okay, when it slides along the curve, notice how it's going to resize all of the spheres, because now that attractor point is sitting in the middle. So the points that are closest to it are going to be really, really small, and the points that are furthest away from it are going to be really big. Okay, but it's never going to exceed this 2 meter radius that I've specified over here. Okay, so rather than having this massive 30 meter radius, or in this case now I've got a 75 meter radius because I've times my formula over here by 5. So instead of having these massive numbers as my radius, I've just restricted it to be 0.01 at the smallest radius and 2 meters at the largest radius. Okay, so I'm going to put this attractor point all the way back to the top again, just so it can be a nice smooth helix, starting at the smallest at the top, going down to the largest at the bottom. And I can export this, and I can take this into Revit if I want to. So I'm going to right click and I'm going to say export, and the file type that we can use here is the SAT file type. So I'm going to select that. I do need a file path node as well, so I'm going to right click and I'm just going to type in file, and there's my file path node. So I'm going to specify where on my computer I want to save this SAT file. So I'm going to browse and I'm just going to place it onto the desktop. Let's just call it Dynamo test. Plug that into the file path. change my units here to meters, and now I'm also going to plug in my geometry that I want to export. Okay, remember Dynamo is dynamic, so just connecting that last one up has already exported that file. I don't have to do anything else here. If I go back to Revit now, okay, I can see that here in my conceptual massing environment, this thing has built itself as well. Okay, I can create actual Revit reference points at all of these locations if I want to do that as well. I'm not going to do that at this stage. I'm just going to go back to my level 1 plan over here. I'm going to go to my massing and site tab, and I'm going to create an in-place mass. Because remember, I'm creating a conceptual mass over here, so I want to put it into an in-place mass so I can use my massing and site tools to generate walls, curtain walls, floors, etc. Here in my conceptual, in my in-place mass, I'm going to go to my insert tab, and I'm going to link Cadfael. I'm going to change my file type over here to SAT. Navigate to my desktop, and there is my Dynamo test that I just created. I'm going to say open. And I'm going to say finish mass. Okay, so if I switch over to my 3D view, sorry, that's my conceptual mass. Switch over to my 3D view, my project view over here. There is my structure here in Revit. Okay, now remember, this is an SAT file, which means I can interact with it using my model by face tools. So for instance, I could go, if I wanted to, and create curtain walls over all of these spheres if I wanted to do that. So I'm going to select curtain system, and I'm just going to select the sphere over here, and I'm going to say create system. Okay, if I switch my massing off to take a look at what that's done at the moment, okay, it does not look very great, not very impressive at all. What I do want to do before I actually create this system is I want to just manipulate one of the settings over here, which is going to be my grid system. So I'm going to go into my type properties. I'll leave it as fixed distance, but I'm just going to reduce this quite greatly. So 500, 500 spacing, say okay. Now I'm going to repeat that exact same step again. And it's going to be much cleaner, much better. Okay, and obviously I could go through my entire helical structure over here, and I could create curtain systems for all of these items. Switch my massing off, and then I've got some really interesting forms that I can work with. Remember, this is parametric, so if I want to change this, I can just go back to my Dynamo graph, update it, come to my manage links, go to my CAD formats, reload this, and then I can just update to face all of these items to get them to adhere to the new helical structure that I've created. Okay, so that's it for this particular video. I just wanted to share this with you. Let me know if it is interesting, if it's going to be helpful at all, if you have any questions, and if there's anything else that you would like to see. I'll see you guys in the next one.